Hi there, this is session 11A of programming from the very basics using Python. Session 11A, well, this is just an add-on session to session 11 where I did cover if condition. I thought maybe it'll make more sense to cover more examples, so session 11 spilled to 1 hour. So I thought I will just create this add-on session where I will give you more examples for using if condition. So in this video, we will see smaller examples in here, different use cases for if condition. All right, let's get started. So let's take one more example for checking conditions. Let's say I want to find out whether I'm given two numbers. I want to find out which number is big. It's a very simple exercise, right? It's a very basic exercise for most people learning if condition. I skipped that in the earlier session, so let me cover that. Let's consider two variables here. A is equal to 10, B is equal to 20. I could take this from user input, but I'm keeping it short and simple, but you can always elaborate. You could say A is equal to int of input of enter first number, B is equal to int of input of enter second number. You can also do that. So I find it more time consuming to type all that and test it. So I'm just hard coding the numbers here for now. Now, among these two variables, I want to find out which variable is representing a larger number, a bigger number. So it's pretty obvious when we read it. We can see that B is bigger than A, right? But how do you check this? Let's say I want to check whether A and B, right? Which one is big? So I will just try to, one of the ways to do that is using the ternary if expression. So one option is you could directly use A is larger than B if A is greater than B. Else, I could actually directly say B is larger than A. This should work, right? So we'll try this now. It says B is larger than A. It's not pretty obvious because B is 20 and A is 10. If all I try to change the value for A to 30, you can see the answer. It shows A is larger than B. Yeah, it looks good. But what if both of them are equal? I could try to say both A and B are equal. It breaks, isn't it? The reason is because when you use a ternary if expression as is, it's going to check for this condition. Is A greater than B? Well, if A is 30 and B is 30, this condition is false. It checks whether the condition is false. It's going to blindly evaluate what you pass in the else part of this expression, right? But this is not semantically correct. It's not. B is not larger than A. Just because A is not larger than B, you cannot entirely assume that B is larger than A. They both are equal. So how do you take care of this? One option is by chain loading the ternary if expression. Quick warning, don't do this. Okay, I'm going to tell you how it is done, but this is the kind of code that you should generally avoid because it just makes it more confusing. These are ways you can abuse your syntax grammar to write code that is completely unintuitive, right? You don't want to do that, but I'm just showing you anyways. So here I can just check if at all this condition is true where A is larger than B, then you want to just evaluate this, which will get printed when you have a number like, say, slightly larger number like this, right? You can see that A is larger than B. This looks good. But if this condition is false, you want to check whether they both are equal first. That's another condition that you need to check, whether they're equal or not. If they're equal, you want to print they both are equal. Else, it's very likely that B is larger than A. That is how you want to check that. So you can chain load this by using B is larger than A. Let's leave it at this. If B is greater than A. Else, both A, I can say both are equal. Now this time it shows that A is larger than B, but if I make both A and B look identical, it shows both are equal. If I try to say B is 45 and A is 40, it shows B is larger than A. But when you go and try reading this expression, A is larger than B if A is greater than B, else B is larger than A if B is greater than A, else my brain begins to hurt a bit. The moment you start seeing these chain loaded conditions like these in a single expression, this is where things get more complicated. And this is the kind of use case where you don't want to use ternary if. Use ternary if expression only for simple condition checks. If you want to chain load, better use if elif constructs, if elif else, right? So if all I want to formulate this using the if condition, it's better off to type it this way, where I could just type, it looks more structured and more organized. I could say if A is greater than B, I could just print A is larger than B. Remember, it's a statement, not an expression. Therefore, I had to use print because you cannot really get the outcome of if statement and store it in a variable. You can't do that because if is a statement, right? That's one thing you should know. This is with Python, by the way. I can type elif B is greater than A. Go to print B is larger than A. Let me just scroll up a bit. Else, I can say print both are equal. Hang on a minute. Yes. Try running it now. This time it says B is larger than A because obviously B is 45 and A is 40. If I make A also 45, you know what really happened? This condition is false. In this case, both A and B are equal. So this condition is false. So it's not going to evaluate the print statement. It checks for next condition now. Else if B is greater than A. Even this condition is false. So the only possibility is that they both are equal, right? It prints both are equal. In case you try to run this again, okay, yeah. If you try to change the number, let's say if I try to make A smaller than B, for example, it shows B is larger than A. So all the three possibilities. So you should know when to use the structured if else kind of conditions versus using the ternary if expression. Don't do this. This is a bad idea. I'll just put a note here. I will not say bad code. I'll not say rather, I'd say maybe not intuitive. Avoid code like below. Right? So rather you should be writing code like this. So that's what you should know, the use case for if, elif, else. There are many use cases like this. You can also use another condition which looks like this. Maybe you could try this out. Maybe try, let's take another use case. Use case example could be maybe sometimes when you're checking for conditions, you're not looking for some continuous values. In the previous session, I think I talked about age. Age is less than 0. I said, are you out of your mind? Because age is between 0 to, let's say, 30. That's age less than 30 is considering from 0 to 30. I mean, 1 to 30, that is. It'll say, welcome, young Pythonista. Then I say, elif age is less than 60. Hello, Python Guru. So you can see that I'm checking amongst continuous possible values, right? Continuous series of values. 0 to 30, one condition. 30 to 60, another condition. 60 to maybe, 80, one condition. 80 to 120, another condition. 150, another condition, and beyond that, right? So you're trying to take a continuous series of numbers and break into different slots and comparing them. But sometimes it might be a little discontinuous where, let's say I want to write a small program to decide when I should sow rice seed and when should I harvest them as a farmer, right? So let's say I'm a farmer and I'm trying to use Python to tell me when I should actually harvest my crops or when should I sow the crops. You know, the sowing and harvesting are done in different times of months in a year, right? We talk about the spring season, the summer season, and all that, depending on what crops you're trying to you're trying to farm. Okay, disclaimer: I'm not a farmer. Okay, so my farming skills are almost zero. So what I know is based on a little bit of Google search. All right. So let's say I want to do it. Let's say I want to find out the right times to sow a seed or harvest, assuming it's, let's say, rice, which is the main crop in India. So I think rice and wheat. It's all over the world, I guess, right? So let's try this. I can just say, I want to know which month it is. So I'm just going to ask for month is equal to input of enter month. I would also indicate to the user the month I expect is in numbers from 1 to 12, indicating 1 is January and 12 is December. So the 12 months, right? So I'm just taking it as numbers to keep things simple. You can also improvise when you learn more to take months from a selection from January, the real words, to December and decide the month number. All that can be done. It's simple at this moment. So let's say the month is, the mostly if you look at different rice crops are harvested and sowed in different seasons. I think depending also on which country it is. I guess in India, I think majority of the or normal rice, I think it's sowed during the springtime. They call. I think it's during the May to July time frame, around that time, and the harvesting happens sometime during October to December or October November, around that time frame. So let's consider the scenario, right? We'll just say if month. How do I check this? I want to say month is between 5 to 7. How do I check this? I can say month is greater than or equal to 5 and month is less than or equal to 7, which could indicate May to July, I guess. I could just print time to sow your crop. Time to sow, let's call this. I could also use another elif condition. I can say elif month is greater than, I think September falls in 9, right? So let's say month is greater than or equal to 9 and month is less than or equal to 12. I could use message time to harvest. Of course, the real actual time to sow and harvest might vary. A lot of things, a lot of factors to consider in reality, but it's a program that we are just learning. So it's okay. Let's consider this as the timelines that we use. So you can see it's very discontinuous. 5 to 7 is like months like May, June, July is when you want to print a message telling you want to sow. And, if it's September to December, you want to say time to harvest. It's very simple as that. What about the other time? We can say time to relax. Now we can just run this. It's going to ask for the month. Let's try the month as 3. This March. Nothing to be done. Actually, in reality, it's not a relaxing time. Farmers have a lot of other work to do, but I'm just giving an example. But let's say I'm a lazy farmer who just cares about just the rice crop and that's it. So if I try to give a month like say 6, you can see time to sow. If I try a month like say 10, it says time to harvest. If I say I try a month like something like some outlier month like say 8, August, nothing to be done, right? Time to relax. Or a month like January, time to relax. So you can see there are conditions can be customized based on different possibilities, right? That's one of the use case for using Boolean expressions like these. But this Boolean expression is a traditional way of doing it. But if you're going to do it the Pythonic way, what would be the more Pythonic way to improvise? Well, you could actually, rather than whenever you have a scenario where you want to check for a value, for a variable, to be between a particular range, between 5 to 7 or 9 to 11, the Pythonic way to do that is by chain loading the conditional expressions, or sorry, comparison expressions. So comparison operators. So I could directly put it this way. I could say 5 less than equal to month, and month is less than equal to 7. It looks more shorter. And even here, I could directly put it this way. 9 less than equal to month, which is less than equal to 12. And this would give you almost the same output. If I try a number like say 4, time to relax. 6, time to sow. It's June, right? Springtime in India. And if we try maybe 9, time to harvest. 12, still time to harvest. But we try something like say 8, time to relax. We try maybe 1, time to relax. You can see that. So if at all you're trying to formulate conditions, and if you have the habit of using multiple conditions, connecting with AND operator, the Boolean logical AND operator, but the point is you're trying to check for a variable to be within a particular range, you're better off simply using this idiom instead. This is something that you should know about usage of if condition. Or maybe you can also write some other program. Maybe another common example could be, print whether a person, whether a player has won or lost a game, right? So maybe based on the score. So I would just use score is equal to int of input of enter your score, which could be between a score of 0 to, let's say, a spectrum of, let's assume, 100. And I can use condition. You can say if score is below 30 for a game, let's assume that you are sort of, not say you lost the match, but lost the game, but maybe you can encourage the player, but say, better luck next time. I can also use elif score. I could say the score falls between 30 less than equal to score, and it falls less than or equal to, let's say, 70. You just print you played well. Else your score is greater than 70, obviously assuming it's less than 100, you could assume it's less than 100 anyways. It can be any number. You could just use print you did great. So this is another example of how you can lay out conditions, right? You can just try number like say 20, it says better luck next time. If you try maybe something like 40, it shows you played well. If you try something like say 80, it says you did great. So you can see how you can perform different things based on conditions. And all I'm doing in all these examples is printing messages, but in real world, you could call other functions or perform other logic. All kinds of logic can be embedded inside this code, right? So this is what you should know about some of the examples that you can apply the if-else conditions. Now, I forgot to mention that in the previous session, I talked about keywords, what keywords make up the compound statements. I forgot what happened in 3.10 at that moment. 3.10 introduced the match construct, right? It just didn't come in my mind when I was covering session 11. And it doesn't come in my mind because I don't use it. Not yet. Because I couldn't find a compelling reason to use it. That's my personal take. But then the match construct in Python was introduced quite recently, just about 4 years ago, perhaps around that time, 2020, I guess. Yeah, it's going to be 4 years now, 3 years. Yeah, by the time I'm recording this video. So they introduced this match construct as Python's equivalent of switch case conditions that you would find in language like C, C++, Java, or in some languages like Perl. I think Perl 5.8 or 5.6 or 5.8, one of these versions of Perl, they introduce given when statements, or even in Ruby you have that, right? They're called as pattern matching, and this kind of interesting names given to it in many languages like Scala and so on. So it's a feature that everyone boasts of that's there in other languages, and in Python world that's lacking, and people are thinking, oh, Python, no match construct. Which world do you live in? So in Python, they thought, okay, the Python community, okay, you want match, we give you that. They added that in Python 3.10. But in my opinion, it's just a syntax sugar. It's not going to give you any special benefit over using the traditional if-elif constructs, because we live with it for almost like 3 decades in Python world before this match just came along recently. It's just a syntax sugar. Some people who have been coming from other programming languages and seriously think that they cannot think beyond using match construct. If else looks very primitive for them, for some use cases is there for that. Well, I'll tell you what exactly match construct does in the Python way. If you're checking a variable, a specific variable, against different possible values, like all these use cases. Here I'm checking the same variable, right? Score less than 30, or score between this range, and so on. Or in the other case, I think I've checked for the month in a particular given ranges, right? Or in the earlier ones, I think age or In this case, it's A and B, right? A greater than B, less than B. I'm checking A against different possible values. Is it greater than B? Is it equal to B? Is it less than B? So one variable against different possible values is like I'm matching a variable for all these possible conditions and performing some activity there. So because I'm not yet fluent in using match construct. Let me be very honest because I don't use it regularly. I'm going to open up the document and show it to you. And then I will just run you through it. It's pretty straightforward. So just one moment, please. Okay, my browser just opens up with whatever I opened last, but it doesn't matter. If you go to docs.python.org, I think this is the Python documentation open up for you. Just go to docs.python.org. And if you just go to Python tutorial, all the flow control constructs and compound statements are covered in chapter number 4. If you ask me, the most important or the most meatiest part of Python tutorial will be chapter 4. Because this is where you learn about if statements, for statements, break, continue, and all the stuff, and all the different constructs and features got with compound statements. You'll find them in chapter number 4. And in here, there's a special section called match statements that's introduced in 3.10. It's covered in here. It says match statement takes an expression and compares its value to successive patterns given as one or more case blocks. This is superficially similar to switch statement in C, Java, or JavaScript, or many other languages, and is more similar to the pattern matching in languages like Rust or Haskell and so on. Right? And you can see the first pattern that matches gets executed, and it can also extract components, sequence elements, blah 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 from those values into variables. All right. The simplest form they tell you about how to use match. Say match variable, and you put a lot of case statements here. Let me just show it to you now. Let's take this example of this harvest. Okay, but no, let's take the example of the harvest time. Let me copy this line. Enter month and takes month from user input. Now I can directly say match month colon. That's how you start. Oh, I'm not sure why Jupyter is or VS Code is highlighting this, or maybe it's not completed. You have to start with case. Oh, now the highlight is gone. Okay, case, and I can just put the case as a specific value. Like for example, I can check against a value like say 5. If it's May, I want to be very strict. I want to say on May I want to do sowing, and on October I want to do harvest. So I can say case 5, time to sow. Case 9, the 9, I think 10 perhaps. October is 10. Print, time to harvest. And everything else, if you want to say everything else, just put underscore here. Underscore indicates like else clause. For all other scenarios, you just want to, caps lock. Caps lock turned on. Print, let me just scroll this up. Print off. I can just say time to relax. Well, I made a mistake here. Oh, forgot the word case. Case underscore. Okay, skip that. And now I run this. You can see that. It's asking enter month. If I try a number specifically 5, it says time to sow. If I try a number like specifically 10, time to harvest. If I try any other numbers, like say 7, for example, it says time to relax. Any other numbers, right? It only checks for number 5 and 10. The month is 5, that is like May, or the month is 10, which is October. It actually matches this case. Month, if it matches the value 5, execute this block. If the value of month matches this case, execute this block. For any other cases, this is the default to indicate default case. In other language, they use a default keyword there, but in Python, use a case underscore to indicate default. You can just say time to relax. But now you can actually make the case more sophisticated if you want to. For example, I can use case 5 or 6 or 7. I can use this pipe symbol to indicate or this is not bitwise or for your consideration. It's just the syntax sugar that's there in Python. Okay, try this out. Let's try 5, 6, 7. So all these three values, it shows time to show. Let's try 8. Let's try 4. Let's try 9. Let's try 10. But now here also I want to make it like say on months, which is 9 or 10 or 11 I want to harvest. So I could actually make this more elaborate. So I can say 5, 6, 7, 9, 10 or 11. So this OR symbol is used to check for different discrete values. You want to check for one particular value, then another value, then another value, then you could use this. But if it's a continuous value that you see here, like 5 to 7 or 9 to 11, I think there's a way to do that. I think there are various syntaxes for this. So you can see one of the options is this. Another option is it's like an OR operator, right? I think you have also an option where you could actually check for continuous values. The way a lot of complexity is embodied in this right now, there's a lot of features that they've added in. All right, let me just check right here. I guess this can take a result of an expression, is it? Let me just try. Let me just try. I'll just say range of 5, 8. Does it work? Let's say 5. No, it didn't work. I thought maybe it'll take range, but no, it doesn't work. It doesn't work against a range object. So yeah. So I think it's either you have to provide discrete values like using or you can put specific values in here. Right? That's the way it is. In my opinion, this is just syntax sugar. As you can see that because I've been an old time user of Python, developer of Python. So this is quite new to me, and I wired my brain to use if constructs all the time, and I find that convenient enough. It is just to cater to, new age programmers who come from new age languages, and they're looking for those match constructs and something similar to that in Python. It might cater to their requirement, right? So hopefully, if I find more interesting use case for match case expressions, I will make separate videos on that because I'm just beginning to use it. So I didn't find real use case, right? But yes, this is what the basic use case of match case construct is. Whether it should use match case or should you use the good old if constructs, well, there's no debate. I mean, it's just your choice, right? So Python has just given you two choices over here. So I find using this was easier. I'll continue using this until I find a compelling reason to say, oh, I definitely need to use match construct because if else won't do. I couldn't find such kind of a use case as yet. So that's me. All right then. So this is what you should know about checking for conditions in Python. I told you that different ways you can check for conditions. And now one of the things I can also add on in this video is that, see right now I'm just getting this month from user input. This is a program. Should it not find out the month on its own? Yeah, it can. It can, right? So if this is a little bit of detour. So let me just take the old code itself using the if-else construct, which is my favorite right now. I'll copy this here. So here it is prompting for the month from the user. Like I had to say when it is, like I had to say it's April or May or so on. But if it's a program, the program should be able to figure out what month it is today, isn't it? Yeah, should be, because most computers have some kind of a clock. They have a notion of time. We can see the time in your computer, not in my desktop. But if you have a proper desktop, you'll see some time being shown, obviously. So the computer knows time. How can you get that? Well, there's a module called time module. There are many modules. There's a time, date time module, calendar module. There are 3 modules in the standard library for matching times and dates and calendar stuff and all that. But the very basic one is time module. The time module actually gives you access to basic time features exposed by most Unix's operating systems. In the Unix world, if you've done some C programming on or writing Unix systems programs, um, Linux, macOS, all these flavors included, there's this time library available. I think it's part of the standard C library, of course, and you get it via time.h. And most of the features related to time management, it all starts from the Unix epoch time. It's also called as Jan 1st, 1970. The timestamps time starts in Unix world from Jan 1st, 1970, 5:30 a.m. Greenwich Mean Time, right? So the Unix time was is number of seconds, ticking from that time onwards. It's called as Unix epoch time, right? Windows might have something similar, but now in modern version of Windows, I think they have sort of emulated those features. If you're using Python, at least, so whether you use Windows, Mac OS, or Linux, it's going to be same. What I'm going to show you now, you can use import time to get access to time module. I think I taught you how to load a module, very basics, right? So you can just load the module from standard library of Python from here. Um, the time module provides a lot of time management related functions, and there are two functions which I had to talk about at this moment. One of them is time.ctime, which returns the current time in a string format, which is largely human readable. The ctime API comes from the C library API. That's why it's called ctime, perhaps. And it just shows up as the weekday and the month and date. And this is the date and time. I'm recording this video, by the way. And it shows what time it is and the year. But this is the whole data that you get here is a string. You can see it's in quotes. Anything that shows up in quotes in REPL, obviously, it's a string. But I don't want this entire date like this. I want just one component of it. I want the month or the date or maybe the hour, minutes, or seconds. I want to get those individual components of your date and time. If you want to do that, you can use another function inside the time module, which is called time.localtime. Whenever you invoke certain functions in Python in a REPL like this, the result, the string representation is what is shown here. They show up like what you see here, this kind of a format. They call this as time.struct time, open parenthesis, and say tm year is equal to 2024, tm month is equal to 2, tm m day is equal to 25, hour is equal to 15, min is equal to, you can see this. When you see a formatted, when you see a data, when you see output in this format, in this kind of a structure, this is called as a named tuple. Named tuple. I told you what a tuple is. It's just a collection of numbers, a collection of items, right? Collection of items. This is more or less a tuple. It's tuple. You can actually treat it like a tuple. You can see that. I'll say t is equal to. If I try to print what is t and type of t, obviously it shows that t is nothing but this data being printed. It's too long, so I'm just going to print the type of it for now. It just shows it belongs to a type struct time. I mean, it's an instance of struct time type. The type called struct time in time module represents the timestamp, but it looks and feels like a tuple, but it's called a named tuple. Why it's called named tuple, you'll see that in a while. So I got this in a variable called t. T is representing that object. If I now try to say t of 0, this is how you access elements of a tuple, right? You can access by using indices. 0, 1, 2, 3. See this. It's a year. 2024. T of 1. What do you get? This month. February is 2. If it was March, it would be 3. If I try to get, let's say, second index, T of 2. 25. Oh, today is 25th of February. Yes, February 25th. Yeah, you can see that's a day of the month. And then you can try 3. It shows the hour. Actually, it's 3 p.m. in 24-hour timeline. It's 15th hour, right? That's how it is. Or we call this railway time in India. So we can try T of 4. I think it's 7th minute of this hour. And T of 5 is the seconds. And you keep running the seconds. Is it seconds? No, it's not T of 4, 5. Oh, I think that's R. 6 is minutes, and 7 is seconds. Oh, seconds. Hang on a minute. I think I missed it somewhere. Let's, if at all I want to convert this whole thing as a tuple, it's a raw tuple and print it, no problem. You can always use tuple like this of t. Only the numbers are available. The first element, second element, third element, fourth element, fifth element, sixth element, 7, 8, 9. It goes on. I think there are a couple of things like the weekday. I mean, it says one of them is a weekday, I guess, and the six is supposed to be weekday, I guess. Day of the week. I think Sunday comes up on as 6. Start from 0. Strange. Okay. Monday is 0. Sunday is 6. So it comes like that. And I think this is supposed to be the day of the year, I guess, year day, and this is supposed to indicate whether uh, this uses the daylight. Is it a daylight standard time? We have this daylight savings, right? So daylight savings time. So it's 0 because I'm in Indian time zone. That could be what it means. So you can see that they keep running this. Oh, okay. Here when I run this, nothing happens because I got the value t. Nothing's going to change because I got the current time as snapshot, and that's there as it is. If you want to keep updating the time, what you should do, you should always run this in this cell. I can say t is equal to time.localtime. That's why I wondered how come seconds didn't tick. Made a mistake. Yeah. So say t is equal to time.localtime and then say print tuple of t. You can see this. See one of these numbers, this number keeps ticking. This is seconds, right? This looks like hours, minutes, and second. So you can see every 1 second it keeps ticking, right? So if you know these fields, you can access them. If you don't know what these fields are, no problem. Just print t as it is, and it'll give you a hint. It says year, tm underscore mon indicates month. Then the day of the month, that's m day, hour, minutes, seconds, and what do you get after that? I think you get it says weekday. 6 is Sunday. I think 0 is Monday. Monday is 0. The day of the week starts from Monday. Okay. So Monday is 0, Tuesday is 1, Wednesday is 2. It goes on all the way till it hits 6 when it's a Sunday. A day of the year. It's like 56th day starting this year. Okay. So that's what it means. And yeah, January had 30 days, 31 days, and now we are in February. And it's showing you whether it's a whether there's a day, is it a daylight saving time or not. This depending on the time zone. If you live in the non-Indian time zone mostly, if you're not in the tropical region like where I'm in India, but if you live in the US or any other place, I think you have this concept of tuning your clocks every year, right? I mean, twice a year, I guess. That's very weird for me, staying in India. So your clocks run backwards and forwards and march and to calibrate to your season. So, anyways, so that'll show up as one in those use cases. Anyways, so coming to know this now from here, if you want to know what month it is, one way to find out is you should know the index. Like you can just try 0, 1. The first index is month. But in my opinion, this looks a little counterintuitive because you should know exactly in what order those elements are. And we humans have a problem remembering numbers, right? Remembering all these numerical things, we are not good at it. So there's a better approach. The concept of named tuple is that you can access every item of a tuple by indices like this. And I shall tell you can also get the slicing operator working here. I would have covered in the gist when I talked about assignments that you can extract slices of a tuple packing, tuple unpacking, remember? So where I told you, you can get the first 3 items of a tuple, for example, by using :3. Year, month, day. So you can actually store it like this. You can just type year, month, day is equal to this. And print them all. Year, month, and day. You got it? Right? We can use the slicing operation, just like you do it in a tuple. But if you just look for a specific field, let's say I want to get to know what month it is right now, just use the name for it. You can just type t.tm underscore mon. What you get when you print it in a REPL. So when you print this back, I'll just create another cell below this. And if I print t, you can see this. So whatever keywords you see here, the keyword identifiers that you see here. It's not keyword. It's called keyword arguments actually. But that's the identifier actually. So whatever identifier you see here, you can use them as an attribute. If you want to find out what year it is, you can just type tm underscore year. You can also chain load it right away. You can just do it like this, assuming that you did an import time and then did a time dot local time dot tm underscore year like this, right? This is how we can find out the year. Or you can use tm underscore m day to get the day of the month. So yeah, now you know how you can decide when to harvest and when to sow automatically without you having to type the date or time, right? So we can actually modify this code, which I just copied here. Instead of expecting it from the user, I could just remove this code off. I could as well commented it, but I told you not a good thing. So I'll just type import time and say month is equal to time dot local time dot tm underscore mon. I got the month. I want to know whether current month is the time to harvest, time to sow, or is it time to relax? Yeah, it's time to relax. If you run this program maybe during the time of May, then you know that it'll tell you time to sow, right? So this is how it is. So you can get time based on the time module from here, right? So these are ways you can gather information. Another use case, so what other use case I can think of? Let us say I'm jumping a little too forward here because I do have time, I guess, another 20 minutes. I'm going to make it an hour, right? So I'll make it a short video, but I'll stretch to an hour. So I want to teach you something interesting. Modules are means by which you can do wonderful things. It gives you magical superpowers in Python modules, right? So if you know what modules are available for different use case, you can do wonders. If you install Anaconda Python, like you did following the instructions I gave you in session 1, you can continue this. We can actually do this. You can try import requests. Requests module, this module is not part of the Python standard library, but it's a very popular third-party library, very well-written library in my opinion, perfectly designed library. So if you ask me a truest example of a very Pythonic design of code, request module is one example I would definitely recommend because it's a well-designed module, so very intuitive, so very readable, right? It's very, very programmer friendly. Before requests existed, people used to use modules like HTTP lib and URL lib, URL lib2, and all that mess, and your code used to look very complex. Requests sort of simplified the task of automating web. It's a library for basic web automation. When I mean web automation, it doesn't mean it just goes and clicks, opens up a browser, clicks on buttons and all that. No. Your browsers, the web browsers that we all use, how do they display web pages? They communicate over the internet to websites which are hosted on different data centers. I'm oversimplifying the whole concept here. By the way, I'm not teaching you web completely at this moment. I'm just giving you the basics that you need to know as a layman, right? So when you open up a web browser and type in some URL, let's say google.com or python.org or something, basically the browser is going to use the HTTP protocol or a HTTPS protocol to send a request to a website that's hosted in the data centers based on the domain that you have used, right? It goes through DNS and all the stuff. That's the thing which I'm not focusing on. But it ultimately locates that website, which is hosting a web server, by the way. It's a HTTP server. HTTP is the hypertext transfer protocol. And this works with some kind of a commands, right? You send a get request and you get a page, or you get some resource, I would say rather. Any resource. It could be a web page, it could be an image, it could be a document, it could be anything, right? It's a resource that's hosted on the site. That's how you download stuff from the internet. Mostly if you're using the browser to download it. So you're sending requests to it, mostly a get request or sometimes even post request when you're submitting forms, filling up forms, or if you're doing other stuff, you could also use the browsers internally could use head request for cache negotiation and all the stuff. So this is the command sets of what we call as HTTP protocol. If you know how the protocol works, without using a web browser, we can still pull in data from web pages, scrape data from web pages, and do a lot of interesting things with it. In fact, this is one of the precursors for data analytics. So if you're doing data analytics from existing web, you want to surf the web pages, or you could say crawl web pages and pull in all the web pages, scrape data from it. The primary module that you normally use is requests. There are many other modules which are built based on request or doing something that request does with more grander use cases, but this is the basic one. Why did I use this? Let's say I want to find out what's the weather in a particular city or a particular location. I could actually use request module to do it, or maybe I want to just pull in a web page. For now, I'll just do one thing. I'll just pull in a web page from my website, and I want to check whether it works or not. So I'm just going to do this. I can say import requests and say response is equal to requests dot get. The easiest way to pull in some data from a web resource is by using a method called get. Get is a function inside request module, which is a wrapper on top of other things, which will not go down in this moment. But the basic use case, you can just say request.get, type in any URL as a string. Let's say HTTPS. Let's type python.org. I'm going to pull in the home page of python.org. I can do that. And once I send a request like this, I get a response object. And if you try to print it, that's why I call you, it's intuitive. It shows what it is. It shows response and in square bracket, it shows 200. The string representation says the response status is 200. Very intuitive. So when I try to print response, it says response object is there, the status is 200. But programmatically, I want to check whether the response went through correctly. How do I know it? Whenever you send a request to web pages, websites, sometimes you get this infamous 404, page not found. These days, browsers don't show that. They will put their own embellishments, right? In early days, you get a 404 not found, page not found, 404. You remember back in the days when we were using internet in the days of Internet Explorer or the very traditional versions of Mozilla web browser, right? Not the Firefox, let's say, the older versions of the internet web browsers. So if all those are nothing but response codes. The response code is 200 or 200 series. It means the request has gone through. But if it's a 400 series, you go sometimes get a 403 forbidden, 401 unauthorized, 404 page not found, of course, and many other 400 series exists. So you can find that out. We can just try response to check whether response is okay. The Pythonic way to check it here, if response dot okay. That's a attribute that represents whether it's true or false. If the status code is 200 series, it'll return true, otherwise false. And then I can just print response dot headers. It says the connection is keep alive, content length. What is the content that's fetched? How big the content that's being fetched? This is a dictionary. When you see curly braces with key colon value separation, this is a dictionary, right? So you can also try something else. You can try some other. You can just say else. It's a print failed to fetch the web page. Let's try something else like this. Some arbitrary string. You see that? The response is not okay. If you want to print more details on what really went wrong, you can actually print response.status. Oh, there's no status. I think it's called, is it called status? Status code, sorry. Response.status code. I forgot the attribute name. See, status code, it shows 404. You can see I'm using if-else condition in real world where I'm trying to do certain things like hit a website, check whether the page is available. If the page is available, I print the headers, but I can also get the content and store it in a file if I want to. All that can be done. Just keeping it simple at this moment. Else, I can do something else. I can just say print the status code. Why it failed, right? All these things can be done. So these are some examples on how you can use if-else conditions, if-elif constructs in various ways in your program. In fact, when you're building any sizable program in any language, it's almost inevitable that you will encounter conditions. Conditions and loops, the two inevitable reality in programming logic. So you want to try these statements out many a times, get a thoroughbred understanding on it, and have a clear understanding on how they work what they do, right? It's very important. So once you know how conditions work, if else conditions, match case, a syntax sugar, if you don't in Python, you can live without it. Okay, I can tell you that right away. So it's just there, it's just to please other programmers. In Python, a lot of new features get added over time just to uh, cater to the requests, or rather I will say the requirements of programmers who come from other languages, especially to give them that comfort zone. One of the other things I could tell you is that, if at all you want to find the square root of a number, I'm surprised to see this. In the math module, if you say import math and say math.sqrt of 2, and then I realized, why did they create this? Because you can anyway find out the square root of a number in Python without having a separate function where you have to get it from a module. You could do 2 to the power of 5 or 2 to the power of zero point 0.5. Half, right? 2 to the power of half. You get the same answer. In fact, if you look at the SQRT functions, implementation is just this. So when this is available as an operator, why do they have a function in a module, and why do you have to do this? This is for people, let's say people who come from Java, for example, in those days, in 2000 era, they jump onto Python, they search for SQRT. Where is SQRT? Where's SQRT? Where's SQRT? They don't know that power of operator exists. They might have not really seen it. Self-learners, right? So they know that there is SQRT as a method in math class in Java. So in Python, they created a similar field for them so they can have their comfort zone, right? But slowly you want to break away from them and live with a pure Python world. That's what make you a Pythonista, right? Anyway, so there are a lot of features in Python which is there, but not necessarily something that you should use. It's good to know them, good to know what they do. If you see in a code, you know what they do, but that's about it, right? All right, then. So with this session, I'm just going to stop this video at this moment. So yeah, I hope you've learned much more about the if-else conditions, if-elif constructs, with some more examples to follow as I go along covering other concepts now in the further sessions. And yeah, as usual, if you really like what I'm doing, yeah, hit the like button, hit the subscribe, and yeah, do share to others who might find all these kind of videos more useful to them. And hope to meet you in the next one. Thank you very much.